We're going to do a little bit of AP review. Right now we're going to be doing the 2009 Form B, BC Calculus for Response 1. It is BC only. In 2009 Form B, question 1 was different for AB and BC. So a baker is creating a birthday cake. The base of the birthday cake is the region R in this very poorly constructed version of a graph that I have, but it's much better on the actual paper. It's the region bounded by y equals f of x from 0 to 30. So you can see the 0, you can see the 30, and you can see that this is my f of x, which is defined as 20 sine of the quantity pi x over 30. They also do the solid of giving you the derivative of f. It's not a difficult derivative to find, but they told you that f prime is 2 pi over 3 times the cosine of the quantity pi x over 30. All right, so part A. The region R is cut out of a 30 centimeter by 20 centimeter rectangular sheet of cardboard, and the remaining cardboard is discarded. Find the area of the discarded cardboard. So this is a clever way to just ask you the area of R. So the trick here is that if I wanted to find this area of R, right, if we want this R area, right, so R should be the integral from 0 to 30 of f of x dx. And I'm allowed to call it f of x because they called it f of x in their notation. We're allowed to regurgitate the notation we see. But what they want in part A is they want the area that you get if you take the amount of cardboard, right, which was 20 by 30, so 30 times 20, right, that would be the cardboard, minus the area of R, which is the piece that you're actually keeping for the base of the cake. So this is the setup that you want, and then honestly, you're allowed to type this in your calculator. They need to see this physical setup, right, that you're doing the cardboard minus the area that's the base of the cake, and then you're just going to type in your calculator, and you're going to get 218.028 centimeters squared, because these measurements are all in centimeters, and it's area, so it should be centimeters squared. A couple things to note. The easiest way to put this in your calculator, right, is to put in y1 20 sine, and then in parentheses, pi x over 30, right? Then you're going to press math 9, which gives you function integrate, right? y1 with respect to x from 0 to 30, right? So what I'd probably put, honestly, if I were typing this in my calculator, I'd type it all in one fell swoop, and I would probably be too lazy to even do 30 times 20. I mean, you certainly can, and you can go ahead and get that at 600, but it's fine to type this whole thing in your calculator, hit enter, and you'll get this answer right here. Again, calculator notation gets you no credit on an AP, but it's worth knowing how to put things in your calculator. All right, let's talk about part B. So that was my part A, right? Part A was about area. When you're given a graph like this, it's a fairly good bet that part B is going to involve some kind of volume. And since this is a BC exam, it's fairly likely that part C will involve some kind of arc length because that's a BC only topic. So part B, the cake is a solid with base R, right? So this is the base of the cake. Cross sections of the cake perpendicular to the x-axis, meaning running this way, right, are semicircles. If the baker uses 0.05 grams of unsweetened chocolate for each cubic centimeter of cake, how many grams of unsweetened chocolate will be in the cake? Well, that's tricky because now suddenly they're making you do unit conversion and figuring out how much you need. So the first thing we need to figure out, since it's a certain amount of unsweetened chocolate for cubic centimeters, we need to find the volume. So what B is asking you to do in a tricky way is it's asking you to find the volume of the cake, right? Now, coming off of this cake, and I'm going to use a different color for this. So coming off of this cake, I have semicircular chunks. So like there's a smaller semicircle here and a slightly larger semicircle here and a slightly larger one here, etc., etc. So remember, we've used this when we talked about volume as cross sections before. I compared it to a dish rack, right? These are semicircular dishes that are standing up. So when I want to find the volume, my job is to find the area in terms of x, and the reason it's in terms of x in this case is because it's perpendicular to the x-axis, right? So I want my area in terms of x, and then the volume is what's going to happen if I integrate from 0 to 30, because that's the first slice to the last slice of my a of x dx. So your primary job in these volume questions is to figure out a formula for the area. Well, let's go through what we know. We know that the area of a semicircle is 1/2 pi r squared, right? So I know that the area of a semicircle should be 1/2 pi r squared, lowercase r meaning the radius. Well, if I want to figure out what this radius is here, right, like the radius of the semicircle, it seems to me that it's this length, top minus bottom, divided by 2. So in this problem, the radius is the top, which is f of x, minus the bottom, which is 0, all divided by 2, meaning my radius is essentially an f of x over 2, right? So that means that the area in terms of x of this whole thing is 1/2 pi times this whole f of x over 2 quantity squared. So there's a couple ways to do this. There's a good chance that you already have f of x in as your y1 because that's what we did in part A. So I'm going to suggest that if I go ahead and square this stuff, this ends up being a fourth, so I get a pi over 8 times whatever my f of x is, quantity squared. Well, as long as I can write that that's what my area is, I know that the volume should be the integral from 0 to 30 of pi over 8 times this f of x, quantity squared. And at no point did I invent notation. I used their notation of f of x, so that's absolutely fine. So this is my setup for what the volume is going to be. I can then find the volume by typing into my calculator a pi over 8 in front of my function integrate, right, in front of my function integrate. And then what I'm going to integrate is I'm going to integrate y sub 1 squared, right, so y1 squared with respect to x from from 0 to 30. Every once in a while, my brain just flakes a bit. All right, so I'm going to get that quantity, and when I do that, I'm going to get that it's a 2,356.194 centimeters cubed, right? Now, if I were you, I would store this as A. The reason I would suggest that you store it as A is you're about to do some other math with it, right? That's not my final answer. The final answer that they asked wasn't what the volume of the cake is, but rather how many of these 0.05 grams of unsweetened chocolate you would need. So what I'm going to have to do to that, you can store it or you could just hit enter after. The last step in my problem is going to be to convert this answer, right, which is the volume in cubic centimeters, times the 0.05 grams per cubic centimeter. The cubic centimeters will cancel, and I'm going to get that this volume that I got times 0.05 should give me my grams of chocolate. So I'm going to get that my answer is 117.809 or 810, depending on if you round or truncate, grams of chocolate. And you could just use G for grams. I wrote out the word grams. Either of those is fine. All right, let's talk about Part C. So Part C is the first part that actually involves BC calculus, and it's the reason they did you the solid of giving you f prime of x. Part C asks, find the perimeter of the cake, right? So the perimeter of the cake, right, means the length of this edge going around, right? So just to recreate that for a sec, that's 30 units on this side plus whatever this arch is, right, which is a question mark. But that question mark, so this is my part C, that question mark is the arc length of f of x from x equals 0 to x equals 30, and we have a formula for arc length, right? So the formula for arc length, right, so this arc length that I want, should be the integral from 0 to 30 of the square root of 1 plus f prime of x whole quantity squared with respect to x. This is the arc length. The perimeter should be this 30 plus the arc length. So I should get that my perimeter is this arc length answer plus a 30. That's my perimeter. So I'm going to type this in my calculator. Now, I would argue that here, the smartest play is to go ahead and put f prime in as a function in your calculator. So this is the work you need to see in order to get your perimeter correct. But what you have to know how to do is you have to know how to type this in your calculator effectively. So either you're not going to use y1 again at this point because the problem is over, so you could just overtype y1, or you could use y2, it doesn't matter. In my y2, I'm going to type a 2 pi over 3 times a cosine of pi x over 30. That's going to be my y2. I'm then going to press math 9, which is function integrate, and I want to integrate the square root of 1 plus y2 quantity squared, close the parenthesis, with respect to x from 0 to 30. I'm going to take that answer, which gives me the arc length, and add it to 30, and what I'm going to end up getting is an 81.803 or 4, depending if you round or truncate, and it's centimeters because it's measured in a linear length, right? It's a length, not an area or a volume.